Hello guys, welcome back. Today we are going to discuss about a topic on storage structures in food process engineering. In storage structures, which includes the deep bin, shallow bin. So these are the concepts which might be useful for you to solve the problems in gate examination as well as for state public service examinations. According to the storage structure, you see the storage structures can be broadly classified as silos and bins. Silos and bins are used to store the grains. So there are two types of bins which is situated based on the dimension. One is a shallow bin, another one is a deep bin. So shallow bin, when you are going to find out the shallow bin, means the shallow bin is nothing but when this is the plane of rupture. When this plane of rupture meets the grain surface before it strikes the opposite side of the bin, it is known as a shallow bin. So the depth of the grain is less or equal to the diameter. The equivalent diameter is 4 times the hydraulic radius, which is nothing but 4 times. H is equal to 4R. 4 times the hydraulic radius of the bin. So the formula becomes H greater than L tan 90 plus pi divided by 2. So R is a hydraulic radius. Hydraulic radius means area by perimeter. Area is nothing but the diameter of the bin, D divided by 4. So pi denotes the angle of repose of the material, and A denotes the area of cross section, and P denotes the perimeter of the bin, and D is the diameter of the bin, and H is the depth of the bin. So this shallow bin has been used to store the grains. So next, this shallow bin has been divided into two types based on this Rankine's theory as well as another one is the Airy theory. So according to the Rankine theory, the intensity of the lateral pressure exerted by the grain in a shallow bin. So PL is equal to WHK, where W denotes the specific weight of the grain and H denotes the depth of the grain, and K is the Rankine's coefficient. So K is nothing but the lateral pressure by vertical pressure. You see this lateral pressure is 1 minus sine theta divided by 1 plus sine theta. So here theta represents the angle of internal friction of the grain. So this is the grain. So this theta represents the internal friction between the grains. So this theta, and pi represents the angle of repose of the material. You saw what is the angle of repose? This lateral surface and to the top of the bin. This angle represents the angle of repose. Angle of repose. So K is Rankine's coefficient. It is lateral pressure by vertical pressure. So where when the angle of internal friction of the grain and then is equal to the nature of angle of repose, therefore PL is equal to WH into, instead of K we substitute this value is 1 minus sine pi divided by 1 plus sine pi. So where there is a theta is equal to pi, they have mentioned here. So we can use this formula 1 minus sine pi divided by 1 plus sine pi. This is the Rankine's theory. Note it on the formula carefully. Next one is Airy theory. So Airy theory, Airy has the scientist subjected that the shallow bin has a varies difference upon the volume of contained in the grain, volume that contained in the bin. So PL is equal to lateral pressure, P is equal to WH into 1 divided by root of mu into mu plus mu dash plus root of 1 plus mu square the whole square. This is the formula, where W as usual denotes the specific weight of the grain or bulk density, and mu denotes the coefficient of friction on grain on grain. So coefficient of friction on grain, and mu dash represents the angle of the wall friction and the angle of the internal friction. So theta W represents the angle of wall friction, and theta I represents the angle of internal friction between the grains. So this represents, and theta W represents the angle between the grain surface and the wall. So total load of the grain is equal to density of the grain into volume of the bin. So rho into V, total load. Okay. So H is the depth of the grain. Volume of the bin we can know pi by 4 d square H, and the vertical roll represents PV is equal to pi d square by 4. When K is known as constant, P lateral pressure by vertical pressure. So when you are going to find the vertical pressure, we can alterate this formula, P lateral pressure divided by K. So this is the Airy theory for shallow bin. For shallow bin, there are two theories are there. One is Rankine's theory, another one is Airy's theory. So next we come to the deep bin. Deep bin is nothing but this plane of rupture meets the opposite side before it strikes the grain surface. This plane of rupture, when it meets the opposite side before it meets the grain surface, is known as a deep bin, where here the height of the bin is greater when compared to the height is greater, depth is greater. So we can know h greater than 4r. So h greater than L tan 90 plus pi divided by 2, where pi denotes the angle of repose of the material. So deep bin, the scientist Jensen has derivation to find the lateral pressure. So Jensen theory for deep bin is equal to P lateral of WR by mu 1 minus e power minus mu kh by r. R denotes the hydraulic radius of the bin. So mu denotes the angle of friction between the grain and bin wall. This grain and bin wall angle of this angle denotes the mu. So and K denotes the, as usual, K denotes the lateral ratio of lateral pressure to the vertical pressure, which is nothing but 1 minus sine theta W divided by 1 plus sine theta W. So P lateral is equal to K P vertical. So for a square silo, the length of the side is S is equal to A square. Here we have mentioned here. For a cylindrical silo, side is equal to pi by 4 d square, where d is the diameter. Okay, you all understand the concept, I know. This is the important formula where n number of questions are asked in this Jensen theory. In gate examinations, questions can be asked from a deep bin. Sometimes, rarely only they can ask questions in the Airy theory as well as the Rankine's theory. So these three theories are very important in storage structures. Now we can solve the problems related to this, which might be helpful for you. Whereas this question is asked in ARS 2006, Agriculture Research Scientist examination, which is very easy to follow. First, write the given data, which is present here. Given data: a circular silo having an internal diameter of 3 meter. Internal diameter they had given 3 meter, and clear height of 8 meter. Height they had given us 8 meter. Contains a weighing of 900 kg per meter cube. Bulk density they had given. So we can take it this as rho. Then the angle of internal friction for wheat is, for internal friction of the angle, mu is equal to 25. So we can represent this as tan 25. And then the angle of friction between the wheat and wall. Wheat and wall, mu dash is equal to 24, which is tan 24. Applying Airy theory, calculate the maximum lateral pressure at the bottom of the bin section. You see, this is the bin. We want to find the lateral pressure in the bottom of the bin. Bottom of the bin. So you know the formula for Airy theory. So P lateral pressure is equal to rho g h 1 divided by root of mu into mu plus mu dash plus 1 plus mu square the whole square. Okay, so we have everything here. Want to find the value of tan 25. Tan 25 is 0.466 and tan 24 is 0.445. So therefore substitute all those values. Rho we have no 900. G is the specific gravity 9.81 into h is the height, clear height, which is given in the question 8. So 1 divided by root of 0. Mu here given 0.466 plus 0.466 plus 0.445 plus 1 plus mu square. Mu is 0.466 the whole square. Okay, square the whole square. When you substitute these values, When you multiply this 900 into 9.8 into 8, you can get the answer 70560. So bracket of 1 divided by root of 0.466 into 0.466 plus 0.445 is 0.911 bracket plus root of 1 plus 0.466 square means you can get the answer 0.21715 the whole square. So when you simplify this, you can get the answer 70560 bracket of 1 divided by root of 1.7547 the whole square. When you solve this, you can get the answer 0.56994 the whole square into 70560 P lateral pressure. So you can get the answer P vertical pressure as 22920 Newton per meter square. So P lateral pressure is equal to 22920 lateral Newton per meter square. It should be in Newton per meter square. So this is the answer. So you must know how you are going to solve this problem. Write down the formula correctly so that only you can get the answer, right answer, or else the answer will be get wrong. So next question. A 50-meter high silo is fully charged with 500 tons of grain. So true and bulk densities of the grain, rho true is equal to 1500 and bulk density is equal to 450 kg per meter cube. The diameter d of the silo and void fraction of the grain present in the silo. You want to find the diameter of the silo as well as the void fraction. So what are they given? Weight of the grain is equal to volume into bulk density. Volume into bulk density. So that only we can find out the weight of the grain. Here they had given us pi by 4 d square h is a volume. Bulk density they had given us 450 kg per meter cube and weight of the grain is 500 tons. So convert this into ton into kg, 500 into 1000. So when you solve this, you can get the answer. So 5 into 10 to the power of 5 is equal to pi by 4 d square into h they had given us 50 into 450. You can get the answer d as 5.32 meter. So diameter you have to find it out, and you want to find out the void fraction. Void fraction is nothing but the formula you will already know. Void fraction is equal to 1 minus bulk density by true density or particle density. So 1 minus bulk density they had given 450 and true density also they had given in the question 1500. So when you solve this 1500 minus 450 divided by 1500, you can get the answer as 0.7. So void fraction will be 0.7. So write it down the result. Result is equal to diameter d is equal to 5.32 meter and void fraction is equal to 0.7. So this is the correct answer. So carefully solve this type of problems. We can see in the next lecture or 2 to 3 problems we can see. So you can get the clarity in this particular topic. Thank you for watching this video. Thank you. If you like it, please hit the like button and share with your friends. It might be useful for me to encourage to put the videos. Thank you. Thank you very much.